can do it, you are coming to this application, right? So if you check it over here, you can give it anything, room ID, you can give it Asim Akram, you hit enter over this. Okay, so you are into the chart now. So this is a real time application, right? You will, if you check my YouTube channel, on the channel this tutorial, you will see complete how you can use it. Even you can play the game on this also, right? If you go with the create room, let's say ID 1 2 3 4 5 6, right? Create, it will take few minutes. Start game, you can just hit enter. This is a game which is bingo, you have to be knowledge of this. Okay, you can play this game with two users also. Okay, now the thing is that we have done some of this access. Okay, so this session will be covering for the Kubernetes, right? For the Kubernetes session, what are the prerequisites to, in order to proceed further for the Kubernetes, we require Docker. Okay, and already you have covered the last session as I received the information about the Docker. What is Docker? For the simple terminology, Docker is a containerized application. It will pack your application and it can be deployed in any environment without any dependency. Okay, it is portable. You can take a Docker image from the Docker Hub. Okay, it might be private repository, public repository. With the credential, you can deploy your container. Okay, so now the point is that why we are the Kubernetes is emerging in IT industry, right? When we say Kubernetes, there might be some reasons, right? It might be why, what is Kubernetes, why Kubernetes, right? So this session we will go first on this why Kubernetes is, okay, and how this Kubernetes came into the play in the IT industry and it was involved. And this is a present, this is a future. Okay, so I'll give the present, go with the next slides, okay, and I will continue. So let's start. Okay. See, I'll show you something. Are you aware of the movies, right? Do you have watched? I want response from you students also. Do you have watched Pirates of Caribbean movies, the series, which is Jack Sparrow?
Yes, sir.
Yes. Do you see that you have noticed there is a fight for handling the wheel of the ships, right? Do you remember whoever had take over the ship? He is the captain of that ship, and he has all the controls. Do you notice that part? Anyone? Okay, no issue. When you overview after this session, you just check out. There is a multiple scene in that. There is always a fight to hand over this ship. If you check it over here, the wheel of the captain, right? So whoever handle this wheel, he has control of everything. Okay, so this is something like this. If you check the Kubernetes wheel, this is the same scenario with this itself. Okay, so what do you mean by this? Okay, let's go here. So the word, the Kubernetes, right? It's known, usually it's derived from it known as a pilot and the helmsmen of the ship, as I mentioned over here. The same scene, it might be inspired or it can be coincident, but the part is that whoever has this control of the wheel, he can do anything. He's a master in that. Okay, the same concept they have used the logo of this Kubernetes. The point is that he's controlling this wheel and he's the master, right? He's a captain of the ship. In this case, if we have the Kubernetes control, what he can captain, right? He has the access of Docker containers, right? Whatever the application is hosted in Docker, right? Docker container, the Kubernetes has all the control, the mastermind and everything to manage, to deploy, auto healing, auto scaling and everything. So this is this is the overview which you can keep in mind whenever you say Kubernetes, that is has a control of the Docker container, right? So let's go for the next slide. Okay, now why the Kubernetes is very important? This is the mandatory skills in the current scenario of the DevOps engineer. Okay, in the current market essentials, if you check any job hosting, you will find that Kubernetes is required, the tool, right? So this is a crucial requirement and highlight required, right, for the IT industries. So you should have the skills of the Kubernetes. Okay, if you check any job, like say, let's go for the Naukri.com. If you check only one, let's say 10 sample, you will find mostly in the 8, you will find Kubernetes has to be added in your skill, okay, in your resume. The reason for that is, everyone is looking for the complete DevOps engineer. Without the Kubernetes, you can be a better release engineer, you can be a platform engineer, you can be as an automation engineer, but still you cannot be a complete DevOps engineer in current scenario. Even as irrespective of DevOps engineer, even As a developer also, in some industries they were asking for some MNC company, they are asking the skills of Kubernetes. Okay, so you understand why Kubernetes is emerging and is required, right? If you go for the Docker history, as I mentioned before, okay, Docker, usually you're containing your application, right? So whatever your application is there, you are taking one EC2 instance. Maybe you have covered in last tutorial, right? As I mentioned, so you will package your application. You will deploy that application into any EC2 instance, and you will make the 10 containers of your application, okay, Docker containers, and you will host your application in the EC2 instance, right? Let's, for example, let's say one Docker container, your application container get crashed for XYZ reason. It can be any reason. It can be any DDoS attack on your website for the application. It can be a load, CPU consumption is very high, right? In this case, what will be our step? If you are not going with the Kubernetes, then our step is that we have to go manually into EC2 instance, right? The VM machine. Then we have to look out which Docker container is down, right? We have to check that logs of the Docker container. Do you agree with me? And we have to check, that point, what does it cause the Docker container to scratch it? Okay, then we can spin up, we can restart this Docker container, or we can create new Docker container because we have the images, right? With that, our Docker images of our application, right? And we can do that part of that, okay, to make your application more scalable. Let's say we are going for the 10 to 15 Docker container of your application. You can scale up this part. But the thing is that you require the physical attendance of the engineer. In this case, you have to be available. You have to go, you have to check out into EC2 instance. Then you have to check what's the reason it caused our Docker container to kill or destroy or stop of your Docker container. You have to check the logs. You have to debug and make your container up and running, right? So does engineer is always available to 24/7? No, right? So in this case, what happened? Then the come of the Kubernetes. Kubernetes provides you, auto healing part. Whenever there is a container, when I specify that my application should be working with the 10 containers, right? For example, when 10th container get destroyed, then the information passed to the control of Docker Kubernetes. Okay, sorry, Kubernetes control panel. Then it will spin up one more container. It will add that container, make it applicable, accessible. So now the count's gone from 9 to again 10, right? From the 10, 1 is minus, right? Then it became 9. So what happened? Kubernetes will make it that again 9 plus 1. Okay, so then again, what we have required, this is our motive to have 10 containers of application that is already healed. Okay, this is one use case. Second use case, it can even make it auto scale based on our traffic to our application. What do you mean by auto scale, right? So let's say I'll give one more very, very best example. Do you watch everyone cricket, right? Do you agree with me?
Yes.
Yes. So do you remember when Virat Kohli plays his match and he breaks the Sachin record? The day the viewers of the hosted application, I think it's what it was Hotstar or JioCinema, I don't remember, but the point is that at that time the view was 4.5 crore. The application view, approximately 4+ crore, which was the highest viewership received on any Indian any sports viewership. Okay, what was the behind of that? Do you find this gimmick? That's the play was Kubernetes. Okay, whenever the request coming from the client in the sense I'm referring to the user, when the user is accessing their application to watch any application, right, to watch anything like cricket, so automatically the Kubernetes start creating the container for the users. Okay, that containers is known as pods, okay, in the Kubernetes terminology. So what happened, based on your scaling up the user viewership, okay, based on the viewership, let's say our viewership is increasing like this, right? So we have to match this, right? So our application containers goes the same way. Whenever there is a drawback of the viewership, and you remember that when the match was at the end, right, after this, and I think he was out, I don't remember, but what happened, gradually the viewership's gone down. Okay, so at the time that same should happen with our resources also, it has to come down. or else we will ended up paying huge cost of our infrastructure, which is not accepted in IT industry by any organization, right? When we say DevOps, when we say cloud architect, right, they're going with the first step, delivery of application should be enhanced. Second is cost optimization, right? So based on our load of our viewership or the client, the application should perform. Based on the drop over the client, the application goes down. You got my point? So this is the player, the behind this, there is a player is a Kubernetes. Same goes with the Netflix, same goes with the Hotstar, same goes with any hosting application which you see in the viewership. FIFA hosting applications, you everywhere will see the Kubernetes is the main player. Okay. The same thing happens with the big billion day. Do you remember the big billion day? How many the users come to buy the things on that use case on your on the applications? Let's say any application, Amazon, any Nike, anything else. You'll be huge, right? So that your application should scale for that event eventually to handle the traffic. Okay. In this case, everything is come with the Kubernetes. Okay. You got my point. Why now the Kubernetes is very important when we can go further with these sessions. Okay. So Kubernetes will monitor your containers in terms of application container into 24 into 7. Okay. And in the Kubernetes, we can mention the specific resources of your to your application also. Let's say one container or one pod can have 4 GB RAM, right? So based on the load, if it increasing on that specific container, eventually it has to auto scale. Okay, you got my point. This Kubernetes will load to traffic to scale the container with the copies of our application and selfie. Okay. And the second point is why Kubernetes has been adopted in the industry is that this is open source. What do you mean by open source is that this is freely available tool. Okay. So, and let's go for the history again. Let me cover one more point, then I'll cover another. Okay. So the thing is, now if you see the Docker versus Kubernetes, what's the overview of this discussion? Docker is a platform which enables developers to automate the deployment of the application using lightweight or the portable container. Okay. Just you convert your application into the Docker image, then you create Docker image to the Docker container, and you deploy to your environment, right? Does not the Docker does not solve the problem like single host EC2 instance as was specified. It can be have multiple container. Whenever we require, let's say our container is down, it cannot provide auto healing, right, without user intervention. Somebody has to look over there. You require 24 into 7 resource of one engineer or anyone responsible for that person. Okay. And auto scaling, whenever the increase is the increase in our load of our application, as I mentioned, reference to cricket or any event, then it cannot scale up to that. Okay. And the Docker is not is a production users. Okay. Singly, if you're going with the application with the Docker, it's not recommended to go for the production. In the production is always a combination of Docker plus Kubernetes. Okay. Docker simple platform. If you check it over here, the Docker, it will provide you one IP, right, of the EC2 instance IP, right? And it does not restrict, there is no such firewall is allowed in the Docker, right? We cannot whitelist any IP address, restrict IP address. We cannot API gateway, or during the DDoS attack, if you found any IP, somebody is trying to put my application in the danger, putting DDoS attack, okay? Distributed denial services, okay? The DDoS referred to. So let's say in the market, you have to keep your application very secure. There is a lot of, there is a healthy competition and there is unhealthy competition also. If we are getting our booming our application and we are emerging, there is a lot of competitors who do mischief things and try to put your application down. Okay, try to destroy your application down. They can do anything. Okay, so that one of the thing is that they will send a lot of traffic on your application at a time from the different IP. At the time automate, you have to pick that IP which is doing mischief thing, and you have to block that IP for your access of your application. Okay, this kind of thing is missing from the Docker. So these all solutions come with the Kubernetes, but still Kubernetes always has been emerging. Okay, so they'll be releasing the latest version is 1.30, but last week they have released new version that is 1.31. So they are already working on this continuously. Okay, so let's go this already. What Kubernetes has come with that? Kubernetes is a continuous orchestration tool. Okay, it can provide you the load balancing, self-healing. As I mentioned that the load can be distributed to multiple working nodes or the different pods, And the self filling, okay, whenever the container is down or your pod is down, right, in the pod the container will be done automatically, it will scale up as I mentioned before. Okay, high availability access deploy complex deployment, I say that it can scale highly. Okay, so whenever we make multiple pods, multiple worker nodes, we are referring to high availability of our application, right? So this part is done. Okay, now let's go with the Kubernetes. Kubernetes, as I mentioned, this is open source and it is highly adopted, right? It's used to design, deploy, automate your deployment, scaling, management of containerization application. Okay, it required effortless management in the sense it's automate your deployments. As I mentioned, that it can be, it can be deployed on the physical server, it can be deployed in any cloud providers, right? Seamless integration of your application like Kubernetes. It is adopted by AWS also. They are providing EKS, right? EKS they are mentioning, Azure AKS they are mentioning for Azure. The Google also, they have Google Engine, right? Google Kubernetes Engine. So this is how they have adopted with the major pair. Even if you're going for another core cloud provider, okay, let's say for Oracle, even they have this one. Even you have another Linode, even they are trying to bring this one. Okay, now let's go for the Kubernetes. Okay, Kubernetes actually developed by Google. This is a product of Google. They used this as an internal system, as an internal tool for their Google organization. Okay, then they called this name as a Borg. Later they renamed as Omega. If you go for the Kubernetes history, you will find this, the history of the Kubernetes. Then afterward, they try to, making their application, Google application, billion of containers and deploying different environments, and they found this is very successful as their internal tool. Then they decided that it has to be evolution. They donated to one organization that is known as Free Organization CNCF. Okay, this is the first project that is donated to CNCF. So CNCF is responsible for maintaining now the Kubernetes. Okay, so as they are the receiver of this donation, they are maintaining everything. They are fixing the vulnerability of this application. They are fixing everything. They are maintaining development of this application, and they are making up to the standards of the IT industry. Okay, so it was released in the production version as 1.0.1 in 2015. It has been around 10 years, right? So in 10 years, this application got boomed. Now every in IT industry, every organization is adopting this tool Kubernetes. Okay, so let's go for the project. Okay, I'll show you this. Okay, when we say open source, right? What do you mean by open source? If you click over here, I'll show you the ping. This is what the GitHub link of this project, okay, Kubernetes. So let me go over here. See, this is the official repository, which is public, right? This is a public. If you want to be a contributor, you can take a pull request. You can add whatever you can contribute to them. If you check it over, there are 3,600 contributors. These are the contributors, these two Kubernetes, okay? This is up to date. The latest version is 1.3.1. Okay, they have released in 4 days ago. So this is update up to the they are getting the releases. How many releases they have? Almost 700 releases. And every 2 weeks to 4 weeks, you will receive one new Kubernetes version with fixing all the things, new updates, new options available which you can integrate. Okay. So this part we already showed. This is available publicly. That means that is open source. Okay. Switch back to this. As I discussed, this is a repository, right? This is an active open source project, and it's received 190K stars. Do you believe this? If you check it over here, how many stars that they received? See, the stars for this repository is 1.9K. This is huge, and the folks are 39K. That means this is very meaningful application, right? Fine. Okay, now the part is that now the Docker and Kubernetes came along with that to make Docker containerization of your application and Kubernetes as a deployment. Okay, and they are working together. We require Docker expertise in order to proceed for the Kubernetes. Okay, so you should be perfect in Docker. then you can work on the Kubernetes. This I will show you why I say that Docker prerequisition is required for the Kubernetes in the lab, which we proceed in the second half of this session. Okay, so now let's go for, as I mentioned, that it's a self-healing, right? For if you give it one use case, right? Let's say that I am requiring my application to be three health instances, right? Of my application always running. Whenever let's say one is down, so Kubernetes what will do? It will ensure that always three instances up and running. Okay, instance in the sense pod. I'm referring to the pods or the containers. Okay, don't get confused for that. Okay, one is dead, it will automatically attempt to spin up with the new one. This we will try in the log in the lab also. Okay, we will try to destroy and we will see does Kubernetes will validate this point. Can we authenticate that okay this is happening or no? Okay, for the theory part, let's cover this point. Okay, now the key concept of this is, as I mentioned, that pod. The pod you will be finding in this tutorial, always to the end of this tutorial, the word as a pod. Pod is the smallest component of this Kubernetes architecture, or the part of the Kubernetes, where you will host host your Docker containers. Okay, the main part is a Docker container will be hosted in pods. Okay, you get this point in the architecture. I will explain further point. Okay, so now let's go for this part where I'm 16th, right? Okay. See, let me just switch it over here. This is the architecture of the Kubernetes. Okay. Can anyone respond that I'm audible clearly for everyone?
Yes, sir. Audible,
Yes,
sir.
sir.
Okay. Are you able to get the points what I have been specifying here? Is it easy, or you want me to be more easy?
Yeah, sir. We can able to get it, sir.
Okay, you are able to get. If you feel any point that just sir, can you be more slow or easy? Please don't hesitate over here. The point of this session is to give some knowledge, to gain some knowledge. I'm also always getting some knowledge from everyone. Like I share the knowledge, is informative for me that I gain some knowledge, right? So don't hesitate. Everyone is welcome. They can give their points. Okay, so this is the architecture of Kubernetes. Okay, if you check it over here, then you will find there is a one block over here and one more block is over here. It's mentioned that node 1, node 2, and this has a control panel. Okay, so let me add some history for this. Before, it was known as master slave concept. Okay, master slave concept of Kubernetes, like the same reference to the point of Jenkins master slave concepts, right? Okay, then later on there is some there is some agitation gone. They say that we don't prefer the word slave. Then they came up with the solution that okay, we will say as a master and a worker. Okay, so this is a master, this is a worker. So if I go for the one hierarchy of our organization, right? Let's say example of our XYZ organization. Whenever the task we receive anything as a employee, right? We receive from the manager, right? Do you agree with me? Your the hierarchy always in the organization is that you will receive your work right from the higher position of you. Okay, so in this case, this is the person. Okay, he is the lead. Okay, let's say that control panel. He is the lead. So he will decide and he will do everything. These are the workers. They will follow based on his request. Okay, you got my point. This is a master. These are the workers. Okay, you can say control panel and the nodes, worker nodes. Okay, so whenever the request comes from any let's say from the owner, then the request has to pass to your manager, right? Any request, then manager will decide which of the employees should handle this request and execute and provide the information to the manager, and then manager will revert back to the client saying that this request has been successfully done. This is a hierarchy which we've been followed in all the organization, right? So it can be different, but this is a usual hierarchy. Here also the same thing happened. Okay, this node 1, node 2, there is no access of internet for this one. Okay, this is only accessible within the cluster. When I say cluster means this is a whole architecture. Cluster refer to the group of servers, right? It's a group of server. This is a one server, which is a master. There is a one more server, which is a worker one. This is node one. There is a one more server, EC2 instance. You can call it VM, as you can call it, right? This is node two. So complete structure is known as cluster. Okay. Whenever the request coming from anywhere, the request first will pass to Kube API server. Okay. Then Kube API server will pass to the information to nodes of the worker, whatever the request is come. So now what we will do it, we will just go deep down and we will cover first point as a worker, what they are. Okay, actually, if you see here, there is a multiple components, right? There is a pod. As I mentioned, your container, Docker container will be hosted in pods. Okay, this is the smallest like component in all the architecture. If you check over here, this is the smallest particle. It has small block also to just to refer that which is the smallest component. If they ask you in the interview also which is the smallest component in Docker Kubernetes architecture, you have to say is pod. What's the use of the pod is that it will be hosting your Docker containers. Okay, your application containers. Okay, so this part is clear to you, right? And the thing is, the next we will cover the kubelet. Okay, kubelet, what's the part of the kubelet? Okay, kubelet is responsible to create the pods. Okay, so it can create multiple pods. Whatever the task he received from the master, it will execute. Kubelet will execute this part. Okay, and one more part, kubelets, what we will do it, always check if our pods is up to date or no. That means is accessible or no. It will check some of the health check, and it will know that the container is accessible, is working up, is up and live. If there is some issue with our containers, is container is down or the pod is down, there is something happen with the container, the information it receive and it will pass directly to the Kube API server. Okay, so the connection of this and all these two blocks is going with the API server itself. This I will cover it later. The part you just try to understand. Kubelet is responsible to check out your containers is up to health or no, right? Is okay, is working, the condition is fine, it's up and running. Is there any crash based on the resources which has been specified is down or something? It can be XYZ reason. If it found anything mischievous over here, okay, let me add with it. Let's say I have said that this pod should have one container, this should have one container, this should have one container of my application. The application, let's say I'm hosting over here the Bingo application. Okay, this is Bingo is a game, you are aware of that, right? The Bingo application I'm being hosting in this pods, right? One container. It can be multiple container based on the requirement. You can host two container in the one pod also, but it is recommended to go with the one container only. Okay, but based on the organization they can specify, but in our use case we will go only with one container. Okay, so now what happened, we have 4 container in 2 worker. One worker is over here, one worker is 2 over here. So let's say one container is gone for any XYZ reason. The reason that, let's say I have given 4 GB RAM, but my traffic came huge, right? So the traffic distributed for over here, suddenly my container got down. So this information will be passed to kubelet. The kubelet will automatically send this signal to Kube API server. Okay, then it will revert back and say that please spin up one more container instead of this. And each pod has unique IP of a unique IP address. Okay, so whenever this containers gets this pod gets destroyed, okay, it's get new IP. Okay, it get new IP. So our use case was to have 4 live containers, right? 4 live containers, or let's say 4 live containers of our application. It's gone to 3. Then suddenly it gave that command, please kubelet spin up one more container to match our minimum requirement of our application. Okay, how you specify this, everything we will specify in one file, which is .yml. Okay, which I will show you in the lab. Okay, don't worry how you will define that, what should be my minimum containers or the pods should be there, and what should be maximum. Okay, so this we are specifying in one file. With that file always will be up to date, and it will say kubelet please go and make it 4 is equal to 4. So it will spin up 4 and 4. So This is the part of the kubelet. Okay, so now if you check it over here, container runtime, right? If you check container runtime, this is nothing but this is referred to Docker engine. You know the Docker engine architecture, right? So we are on the Docker engineer engine, we are hosting right our Docker containers. As you go for the Docker architecture, the containers are hosted right above the Docker engine itself. The Docker engine is interacting with the Docker container, the Docker, and it will Docker daemon, and it will create the Docker containers. So as we are hosting the Docker container itself inside the pod, so here the Docker runtime referred to that. Okay. And the point next, as I mentioned, that Docker kube proxy, right? The kube proxy, what's the meaning of the kube proxy, right? Kube proxy is responsible for managing the network of the cluster, Kubernetes cluster. So whatever this IP you are getting of the containers, right? We have 4. This everything will be stored over here, copy proxies. Okay, kube proxy is responsible for that. And whatever the communication going between the pods, okay, let's say 2 pods or these pods, if everything is paused with kube proxy. Okay, to make it more easy, I can give you one more example. If you're aware of Nginx, right? Do anyone have the information about Nginx? This is a very powerful web server. Can anyone respond? Can anyone respond? Hello?
Yes, sir. We just have a basic idea what Nginx is based on using usage with Docker, but not as a whole Nginx.
Okay, so let me add, let me add the few points. Okay, the Nginx is a very powerful web server. Okay, and web server I'm referring for reverse proxy. Okay, so it's a reverse proxy, powerful engines where you defined, okay, let's say asim.com, I have a domain, right? And I have a front end, I have backend. Let me add over here. Okay, let me delete. Let me, where is the pen over here? Every application has a front end, right? Do you agree with me, everyone? Then there is a backend where you specify the hierarchy or the APIs and everything, how it should respond. Okay. Then you have a database where is a heart of your application. Let's say I have an application with the name of Asim and it's accessible with asim.com, right? For example, for the use case. Okay. Whenever the request come here, if it's coming from the front end, the GUI is a front end, right? It should pass to front end. Okay. From front end, it has passed to the, if they are want to access my any blog, let's say I have a blogs or the post over here. So the front end will pass to the backend. The backend will hit the database because my all news articles are been stored in the database, will fetch this one and it will pass to front end. The front end will be displaying over here, the news channel, right? If you check any news website, you will find the same thing happen. In the back end, this everything will be happening. This is this 3 front end, back end, and database will be hosted separately. Okay, let's say for example I'm hosting 3000 in one 3000 port. I'm making front end, the back end is making on 3010. The database is not is not open to public, that means it's secure, right? So the request I cannot give like IP address with 3000, right? How I can give any user? You say that somebody come, Asim, I want to access your application. So what I can give to them, I can give my URL, right? asim.com. So I cannot give IP/3000. I'll say that please, Rohit, go and access IP plus 3000. You will find my front end. Please take my IP plus 10,000. You will find my backend. So this is not possible. In this case, what happened? I will make one Nginx configuration file, right? With that file, I will specify multiple rules. With that rules, everything I will make is as reverse proxy. Whenever the request coming from here, from my domain, that has to pass to all these running applications. Okay, so the same thing happens. Okay, same thing happens with the Docker, with the kube proxy. Okay, so it's responsible to communicate within the pods. Okay, within the pods, it can communicate with the pods. It can get all the IPs from that pods. Okay, communication between a multiple pod of your application, right? It can even make enable cluster load balancing and service discovery and anything. Okay, and this is the part of worker node. Okay, you got my point. There's a major three things: kube proxy, runtime, and kubelet. Okay, the service in the sense is that IP address, as I mentioned, thus in this part, this is not accessible from internet. Okay, this is very secured. It is only accessible within the cluster. Cluster, I'm referring this for this part complete. Okay, bunch of control panel master and the worker nodes. Okay, so what happened, this has a one IP, as I mentioned, that every pod has one IP, right? But even it cannot be accessed from the internet. Okay, so for that use case, what we will do it, we will make a service. Service will have a one load balancer. Okay, you know the load balancer, right? EC2 load balancer. The load balancer will have one DNS. With DNS that we can access. To make this everything, we required Kube API server. Okay, so now this part is clear to you, right? So let's go for second part. The second part is we have, this is very important, this is as a master, right? This is a master control panel. Okay, if you check in the master control panel, you're able to see that there is a one cloud control manager. Okay, then you have Kube control manager, you have Kube scheduler, Kube proxy, and additional services. Okay, then you have Kube API server. Okay, let's go with one. Okay, so the first point, the Kube API server. Whatever coming, the request is coming from outside of the world, from the browser, from EC2 instance, right? If I want to create this cluster, right, a complete setup, the request first pass to Kube API servers, right? Kube API server will check it out. I'm authenticate to access this, right? Authentication will go, the part first authentication, then the request will proceed to master node, right? All the information what he's processing, that will be stored in etc. Okay, whatever you are doing, everything, that information stores in etc. If you go for Linux operating system also, right, Ubuntu or any other one, you able to find one directory is ECT by default. Okay, whatever the application you're going to install, that it will make all your configuration files inside this etc directory, right? The same you can refer for to remember. Okay, just to make it remember, I'm making it easy. Whatever the information that Kube API server receives, that stores in ECD. Okay, so usually Kube API is a gatekeeper. As I say that whatever the request is coming, so this is a gatekeeper, this is a security guard inside the cluster and to the internet. Okay, because the internet request should pass from here, the browser request, or I'm accessing EC2 instance, I'm integrating this cluster with Terraform, with Jenkins CI/CD, any XYZ, that request should pass with Kube API server only. Okay, so this is a gatekeeper which will receive your information, which will authenticate, then it will proceed further. So this is how your complete Kubernetes secured this way. This is a very secured application. Okay, so now if you go for ECD, as I mentioned that, it stored all your backend of the Kubernetes. As I mentioned that whatever has been happening inside this Kubernetes cluster will be stored in the ECD. Okay, and ECD can only access, right? Who has this access? If you check this line, it has only access to this controller itself. This component of Kube API server can only communicate with ECD. This is how secure. Even these another components or the node worker, it cannot communicate with this. Okay, only Kube API server, it can communicate with it. This is how more secure it is. Okay, now let's go for second one. Okay, let's say Kube control manager. Okay, what is done? Okay, so it's a home of the controllers. Okay, whatever the controllers, if you check it over here, you have multiple controllers with Kube proxy, runtime, kubelet, and everything. So it's control everything. It's act like a manager inside the Kubernetes cluster, right? It will handle all the core controllers. Let's say if I'm going with the anyone replica set, I want to make it one instead of one container, or the pod I want to make it two in the future, right? So this all will be handled by Kube controller manager itself. Okay, it's controlling all this thing. The information pass from here, then it is put here, and the request will be entertained. Okay, so what do you mean by Kube scheduler? Kube scheduler, right? This is a very important, which you may get in the interview always. Okay, so the Kube scheduler will decide, right, where our pods will be deployed. Okay, let's say in my YML file I specified that my application, which is Bingo, right? I required 4 pods of my application, right? 4 pods of my application, right? Let's say 4 port. So then kube shell, the request when from here using kubectl I'm making configuration file, then I'm hitting this control panel, right, to the for Kubernetes cluster. Okay, then the request come here, then scheduler will check which worker node is free as the manager, right? Whenever the request come to the manager will check out which worker is free, he don't have the workload extra. Based on that request, the manager will give that employee to work on this specific task. The same happen with the Kubernetes scheduler, is responsible to distribute the work or the pods, okay, to deploy the pods in the nodes, node worker node 1, worker node 2. Okay, so this part is over here. Kube proxy, as I mentioned, that this is the same which will be handling over here, right, responsible for that. Okay, as I mentioned. Now if you check the placement of pods I mentioned, right, is responsible to kube scheduler. It's responsible to handle this node 1 to deploy all your pods in node 1 or node 2 based on the request. It's always check. Let's say I'm going with the request 3, right? Let's go with the 3 pods. So what happened, it will just check with the help of kube API server with the kubelet. It will fetch the information. Does this node has only one, this node has one deployed pod. So what will happen, then it will decide, okay, it has one, no, so I'll make it one more over here. So it will make 2 over here, then it will make 1 over here because my request is 3. Let's say request increase for 4. So then what happens, it will check it out. The kubelet will check it. I have only 2 pods available, then the request pass over here, it will check over here by the kubelet 1 over here, so the count is 3. Then we will add 1 more over here, so it will come with a 2 plus 2, 4. So this is how this everything can be handled. Now the cloud provider API, this is not a very important, this is only use case when you are using cloud hosted services. Let's say I'm using EKS, right, EKS service or AKS service for Kubernetes, right? So in this case, the cloud APIs, if you're going with any cloud provider, at the time that APIs you can consume to get the information or fetch of your all the information related to your Kubernetes cluster. Okay, you have any doubt over here in the architecture, you can ask me. For the theory purpose, if you don't understand also, don't worry, in the lab I will tell you, I will show you how it actually happens. Okay, so anything more questions, please you can ask now. Anyone?
No, sir.
No, sir. Okay. And my voice is audible, right? It's clear to everyone.
Yes, sir.
Yeah, thank you very much. Now let's go. Let me just close it over here. Okay. So now if you go over here, so as I mentioned, the same will be, let me just from the current slide, right? As I mentioned when I explaining the architecture, the components which I mentioned, the same components over here, the kubelet, kubeproxy, and the runtime engine. They will ask you what are the node components, right? What are the worker node components is available? Okay, they may ask you with the worker nodes or nodes. So just you have to say there is a 3 components available in that. One is kubeproxy, one is container runtime, runtime refer to container D of Docker, right? kubectl is responsible to check it out the health of your pods and pass the information to API server. Okay, so these are 3: kubelet, kubeproxy, kubelet engine. Okay, this already I have explained to you. This everything is going over here. Container runtime, as I mentioned. See, if you check it over here, this is the same container D. Okay, which I have specified over here. Okay. Control panel, if you check for the control panel, the master, what component do we have? We have 5 component in that. Kube API, right? API server we have etcd, which stores all your information, okay, information of your process, right? All the information. Kube controller manager, that is responsible to check everything, whatever the request has been proceed. Okay, and it is basically as a master of the controllers. Okay, whatever the controller has been, it will take the control of that, and kube scheduler will schedule whatever the request is coming, right? It will schedule, it will pass the information to kubeproxy to schedule in the worker nodes. Okay, so based on our information, kubeproxy is responsible to communicate the health of the pods and the health of your cluster. Okay, ECD container runtime is referred to the same thing, kubelet as I mentioned before. Okay, these are three things. Now let me go with the monitor API server. This already. Now the part, let me show the part is a lab, right? Before proceeding for here, I'll show you over there. Okay, so we already discussed this Kubernetes, right? We have this the repository which is in GitHub. This is open source, right? So if you go for here, let me just show you. This is my account, right? To in order to proceed this further, right, for the lab purpose, can we take like 5 minutes break, then we'll proceed with the lab.